Specialty watermelons are carefully cultivated in containers so that the fruits form different geometric shapes. Kurt wants to build molds to grow watermelons shaped like triangular pyramids. All right, and his plan is to have it 2x this way and 4x minus 4 up that way. Okay, so we're going to choose our model first so that we can find the surface area of our mold in terms of x. The watermelon can be modeled using a regular triangular pyramid, right? Because it's triangular shaped down here. So we will be using the surface area of a pyramid formula, which is 1/2 PL plus B. The perimeter of the base of the pyramid is 2x plus 2x plus 2x, which is 2, 4, 6x. The slant height of the pyramid, that's this guy, 4x minus 4. And then we're going to calculate the area of the base, which, remember, area of a triangle is 1/2 base times height. The height of the triangular base is h equals blank, and the length is base equals 2x. So remember, when we have an equilateral triangle, to figure out the height, we have to use the Pythagorean theorem. So we draw a sketch here of the triangle. So we're looking at something like this, and we're trying to figure out what that dotted line is. So a squared plus b squared equals c squared. In this case, our c squared is, the hypotenuse is 2x. So we have x squared plus b squared equals 2x squared. So b squared equals 2x squared minus x squared. 2x squared is 4x squared. So if I have 4x squareds and I take 1x squared away, that gives me 3x squareds. So b is the square root of 3x squared, which is x times the square root of 3. And I don't know if they're going to like the way I typed that in. They did. Go us. All right. Next step, substitute the values into the formula for the area of a triangle to find the area of the base of the pyramid. So we plug in all of our little guys here. And then we substitute the values, so the solution is square root of 3 times x squared, okay? And we substitute the values that we've put in up here into our big formula. So we get 12 plus the square root of 3 times x squared minus 12x. So that is the surface area for our weird shaped watermelon thing. And now they're going to say, okay, what if x is 6? So anywhere we see an x in here, we're going to change it to 6. Okay, so when we solve this, so 12 plus the square root of 3, and then we multiply that by 6 squared, which is 36, and then we're going to subtract 12 times 6, which is 72. and that gives us 422.35. The 5 makes the 3 become a 4, so 422.4. So the surface area of the watermelon, if our x is 6, will be 422.4 inches squared or square inches. And we have a study tip. To approximate the surface area of the watermelon, Kurt assumed that a regular triangular pyramid was a good approximation for the shape of the watermelon. It's a pretty good assumption based on what it looked like in the original picture.